In the second video on matrix basics, we are going to be looking at augmented matrices. We've learned so far, we've learned 3 different ways of solving a system. We've solved it by graphing, which is not very efficient. We've solved it with substitution method, and we've solved with the addition elimination method. There are several more ways that you can solve systems of equations using matrices. Now we're going to look at one of them today. So when solving them, we're going to need to look at, we're going to simplify things a bit, because this is actually a method that would be easy to use in a computer. So when solving systems using the addition method, so when we did that, what's important is the coefficients of the variables. We're looking for two sets of coefficients that are the same number with opposite signs, so we can add them and eliminate them. So it's the coefficients that influence our decisions. Well, each system of equations has a matrix consisting of its coefficients and its constants. That is called its augmented matrix. So we're going to pull out just those things that are going to be important, which are the coefficients and the constants. So here's my system of equations. 5x minus 3y is 7, 2x plus 3y is 22. When we write a matrix, I didn't really point that out in the first video, we put it in a bracket that looks like this. So I'm just going to write the coefficients. So that would be a 5, a -3, and a 7. So 5, -3, and 7, and then 2, 5, and 22. 2, 5, and 22. We're going to keep it in rows and columns. We're going to end our matrix there. We're going to draw a line in between the coefficients and the constants. That's kind of the spot where the equals is in the equations on that left side. So there is my augmented matrix for that first system. For the second system, it's a little bit bigger. It's going to be a 1, 2, 3, 4. So I've got 3 rows. I'm sorry, I've got 1, 2, 3 rows, and 1, 2, 3, 4 columns. So it's going to be 3 by 4. So I'm going to take the coefficients. 2, right here, this is going to be a -1, and this would be a +1. So we're going to have to put a coefficient for all of them, even if it's an understood 1, and then I have a 4. In the second row, I have a 1, a 1, a -3. So 1, 1, -3, then 6, and then 2. And now I don't have anything underneath the y and the z, and I'm going to need to fill something in. So I'm going to put a 0 and a 0, and then put my a. So I need to have all of those elements filled in, and that would be my augmented matrix. So let's go back the other direction in example 1, write the equivalent system of equations. So for this first row, I have 1x plus 0y is equal to 3. And for the second row, I have 0x's plus 1y is equal to -2. Now I'm going to simplify that. So this is really x is equal to 3, and the second one is y equals to -2. B, when I write that first row, I'm going to have x plus 3y equals 4. And the second row is actually 0x's, so I'm not going to write that. 1y, so I'm just going to write y is equal to 4. In C, I have x plus 2y equals to 1. And the second row, I have no x's, so I'm not going to write it. 1y, so I have y equals -5.